Okay, so we are recording this now. Again, this is the INCOSE Requirements Working Group meeting for November of 2021. We have a guest speaker. His topic today is the role of requirements in an MBSE world, which is a very interesting topic for a lot of our participants in the working group. Luis Andes, would you please go ahead and introduce yourself? I'll go ahead and go on mute, and the floor is yours.
Yeah, sure. Thank you, Tammy. Well, thank you everyone for attending this talk. First of all, I would like you to interrupt or to write any question you may have in the chat. Also, if you do not understand my Spanish English, please correct me or also interrupt to make any additional question. Okay. So, who am I? I am Luis Andes Olmedo. As you may know, in Spain we have two family names, but you can call me Luis, as all my former colleagues in Skydweller did. The name is Luis, but probably you will pronounce it Luis. No problem. Well, I studied information technology here in Spain, finished in 1998, and I was doing some software development for 2 years, more or less, and then I started writing in requirements engineering. I didn't even know what systems engineer was at that time, but well, I started working for air traffic management projects. I was involved in the left side of the V for 16 years, more or less, gathering requirements, writing requirements, tracing, managing the quality of the requirements, and well, participating more or less on verification activities, but not directly. Then I had one gap year at 16, and in 2017 I completely moved or changed the sector from air traffic management to airspace, and I was working for 2 years on the right side of the V as a Airbus subcontractor, also here in Spain, writing and executing test cases for the A400M DFDRS, the data recording subsystem of the aircraft. Okay. Then in 2020, I moved to Skydweller. You may know the company. It's a American-Spanish startup based here in Spain and also in Oklahoma, in which we were. They're still doing it. They're building. They bought the Solar Impulse. You may know that platform, and the final goal of the company is to transform the aircraft into an UAV. At that time, I discovered INCOSE. Well, really, I discovered INCOSE sometime between 17 and 19, 2017 and 2019. But I certified this year, 2021, at the beginning of this year. Sometime before, I started collaborating with INCOSE EMEA as INCOSE EMEA Assistant Director for Communications. That sounds important, but it's not. Reality is that I am who maintain and manage the INCOSE EMEA LinkedIn page. Okay, and since June this year, I changed to a new company, Indra, in Spain, and I'm working as System Engineering Capability Lead for the FCAS program. The FCAS program is the Future Combat Air System, an European program between Spain, Germany, and France. Okay, so that's me. And why am I here today? In Skydweller, I had the possibility. Well, I joined Skydweller as a requirements engineer, but if any of you have ever worked for a startup company, you may know that everything is possible. If you have interest in different tasks, you can do almost everything you want. So I started in Skydweller validating requirements and contributing with subject expert on writing requirements according to INCOSE guide for writing requirements, EAS patterns, and so on. But I started participating in the MBSE team because I have a real interest on SysML and MBSE. I could define myself requirements engineering processes and methods, VMB process and method, and also together with a former colleague of Skydweller, we both had to define the MBSE process and method. Okay, how to deal with models in the company, which layers of models we would create, how to link those models with requirements, and when we did that on a test fail approach. Okay, so why am I showing this slide? As you can see there, this is not this is an article that someone that is attending the session wrote in 2019, Lou. So when I agreed with Tammy to give this talk, I said to myself that I should make some Googling on the internet to see if there's some theory on this, because my experience is pure practical. And I found this really interesting article that I recommend you to read, because in this article, you are going to find everything I'm going to tell you today, but also much more information from the requirements working group sessions during the international workshop in 2019. Okay. Do you need to make it larger? It's in full screen. I think I can. Well, I can zoom. Is that better?
It's actually harder because I can't see the entire slide.
Yeah.
For the audience, we are going to make these slides available on our COSI requirements working group page if you're a member of the working group. And I know, Ron, you have some students here. You could probably send these slides to your class as well. So these slides can be available. In fact, I can go ahead and post them now if you want to get access to those links.
Okay. So I recommend you to read this article written by Lou. Okay. What I'm going to explain is, as said there, my hands-on experience in Skydweller with this MBSE process and methods, and how we learned and defined to create requirements and models in parallel. So in that paper, Lou highlighted 3 questions that arose during those requirements working group sessions. First question: are test-based requirements still needed given the increased focus on diagrams, use cases, and models? Second question: can models be used to both help define requirements as well as implement those requirements in design? And third question: can models be used to improve the quality of requirement completeness, consistency, and correctness? I'm going to try answer these 3 questions today, but my answer is yes, yes, and yes to 3 of them. Why? Well, question 1. Text-based requirements are still needed, for sure. Well, it depends, but in the case of my hands-on experience, we had different stakeholders, and for sure, not all of them, maybe none of them, was capable to understand and read SysML, to understand and read models. So how do you communicate with stakeholders, no matter the level? Maybe the customer, maybe the authorities, for example, in the case of others, certification authorities. You cannot, or unless here in Spain, we cannot provide models to certification authorities. They do not know how to read SysML. So you need to provide requirements, text. Okay, the same for supplier, the same for internal stakeholders, high-level stakeholders. For example, chief engineers or system engineering leaders, or not all of them have knowledge on SysML or Arcadia if you're using Arcadia instead of standard SysML. So we do need requirements. If we think on verification, normally verification engineers do not know SysML neither. So you have to give them text-based requirements or system test colleagues, those who perform the test at the aircraft, on ground or on flight. They do not know how to read models, so you need text. Okay, that's why I think that test-based requirements will have to live together with models during a long time, unless you are an organization in which everybody knows how to read SysML or Arcadia or the language you're using to model, and you have all the product lifecycle the models integrated in all the steps of the product lifecycle. But I think at this moment that's complicated. So in this case, we had both work products, models and requirements. They use a set there in this cloud shape. The use of MBSE was a company goal. They decided to use MBSE. We decided that the model would be the source of truth, the unique source of truth. Okay, and due to that, we made all the following decisions I'm going to explain in the next slide. So question one, yes, we do need text-based requirements. Question two, can models be used to both help define requirements as well as implement those requirements in design? I would say not only models can be used, models must be used to define requirements, or this was our approach. Why? If we define models as the source of truth in the system, we are considering that models are going to be the reference for any question, technical question related to the behavior, the structure, and the composition of the system. So you need, or we decided to use models as input for all the any other work product, but we had to face one issue. Technical experts didn't know to create models. We'll see that in the next slide. Okay, but how was the process we defined? Well, I'm always talking about requirements, but I should say also needs. We had no formal needs documents. I mean, we had no needs collected in documents named needs, for example, but we had needs. We had as inputs for from the higher level of the system. We had business requirements, customer requirements, one ConOps, and one master schedule. I'll explain in a while why I've included the schedule here. So we can say that we had the needs in business requirement and customer requirements. Those were not real customer requirements, were guest customer requirements created by the chief engineer, okay, because we had no customer yet. So based on their operational knowledge of the platform and the possible customers we would have, they created a set of customer requirements, customer needs more than requirements. So those were our inputs, and we decided to to split the system in 3 layers, 3 tiers: system, subsystem, and item. At the beginning, we had 4, but system, segment, subsystem, and item. But during this process of the definition, we decided to remove the segment because it really made no sense for us. Okay. So at each level, we had models and requirements. RWG stands for requirements-based system engineering. We have models and requirements at system level, at subsystem level, item level, and then out of system level scope, not under the guidance of ARP, but under the guidance of TO 178 and 254, we had software and hardware levels. They also followed this approach, but that was out of our scope, out of the system engineer scope. Okay. So for system level, we decided to create operational use cases. Can you see? I'm going to zoom in a bit and then zoom out for you to read it better. One question in the chat: text-based requirements. Is it possible for an organization to at least define a grammar which could impose certain syntax and requirements? Yes, it is, sure. You can define an ontology and taxonomy for the requirements. In fact, that would be the next step in Skydweller. That's something we are already doing in my current project at Indra. Okay, we are working on defining common ontology and taxonomy for all the system levels. And well, we are on a system of systems at this moment for all the assets of the system and for the different vertical projects we have at this moment. Okay, so yes, it's possible, and I would say it is beneficial to do that. Well, master schedule. This schedule, based on the final concept of operations, what they did, our bosses, they set an incremental schedule that we called missions to accomplish the final goal of flying at wherever they hate, wherever for 90 days, for example. That was the final goal, the final operational goal, but they defined a set of incremental approaches that we named missions. So what we did is, we are going to create operational use cases based on missions. For example, first flight. First flight was not a fully autonomous flight, just taking off and landing, and still with a human pilot on board. Okay, so we decided to create operational use cases. From those use cases, according to SysML standard, okay, use cases. From those use case based on operational needs, on missions, we could create operational scenarios. This is the name we gave to activity diagrams, according to SysML standard. Okay. In those operational scenarios, we designed the flow of actions to accomplish that specific mission. And from that activity diagram, that operational scenario, we started to decompose to create a list of high-level functions. Okay, so the functional decomposition at system level. Okay, then we have the requirements. From this list, well, let me say that when we started to create the models, we already had needs and requirements. So what we did is to use this functional decomposition to review the completeness of the requirements at that level. We compared these functions with the requirements already written and decided if we had to include some more additional requirements or not. Also, this list of high-level functions were the input for safety tasks. Okay, and from this list of functions, we derived interface requirements, functional requirements, and safety requirements at system level. We did more or less the same for subsystem level and item level. Well, this is a bit different. At subsystem level, we had no use cases. We thought we did not need to create use cases at subsystem level, but activity diagrams. No, not operational scenarios, activity diagrams named as the standard says. Okay, activity diagrams, state machines diagrams, and then the functional decomposition. At subsystem level, the engineers part of the MBSE team started to sit together with technical experts to review their requirements because they already had the requirements. So what we did is, for example, let's say landing gear. We are going to start the creation of the models of landing gear, but I already have requirements. The expert have already written requirements. What did we do? Sit together with the expert, with the responsible for landing gear, review his or her requirements, and then I would create the models on my own. When I had first set of the models for landing gear, I would sit together again with the landing gear expert to review the models and the requirements together and see if there's something in the model that should not be there, or there's something in the requirements that has to be, there's some lack on the requirements, especially regarding the interfaces. The models were especially useful to detect inconsistencies and lack of interface definition. Okay, and also we created functional decomposition at the next level, so system level. We had to face also the issue that most of the experts, technical experts, didn't know how to properly write requirements. So when they started to write requirements, they were writing more books than requirements. So we consider that providing the functional decomposition to the technical expert, he or she would create the requirements based on that list of functions for her subsystem. Okay, so the idea was, this is the list of functions we've defined using the models, designing, analyzing the activity diagrams, the behavior and the structure of your subsystem. These are the functions. You have to create requirements for one or more requirements for each of the functions. Okay. Well, again, interface requirements, functional and safety requirements. At these two levels, more at subsystem level, we had functional decomposition and functional architecture. Okay. And then at item level, the process was a bit different because we had no physical architecture at subsystem level yet, but physical architecture was introduced at item level. So at this level, we had functional architecture, functional decomposition, activity diagrams, state machines diagrams, and also physical architecture. And we allocated functions to items, okay, logical functions to hardware items. And that was also the input for safety analysis at this level. And we did the same with the expert. we started to have meetings with them, sit together, review the requirements they already have written, start creating the models, and then iterate together, model-based with requirements engineers to review requirements according to models and models according to not requirements, but according to the knowledge of the expert, okay? Because they did not know how to create models, okay? And as I've written here at the end of the slide, we had MBSE to requirements traceability at all levels, okay? Functions, functional and functions and interfaces. We had traces between requirements, functional requirements and interface requirements to functional decomposition and to interfaces in the models, okay? There are some more questions on the chat. I'm going to try answer before into the next slide. Jose Miguel, Jose Fuentes, Wayne, there are, well, yeah. Jose says that there are well-known grammars like ears or sophist. Yeah, correct. Lou, the link to your paper. Thank you, Lou. Jose Miguel Fuentes, personal recommendation, do not reinvent the wheel, tailor the existing ones as much as you need. Agree, fully agree. Tammy, ears is good. We can also use the INCOSE guide. Yes. We use the INCOSE guide for writing requirements in Skydweller, and we are already also using the INCOSE guide for writing requirements in my current project at Indra. We are going to tailor the guide, not tailor, but to reduce the number of restrictions the guide imposed, to start with a minimum set of norms, so to say, okay? Wayne, this is good to know. Frequently requirements get written with certain elements missing. Yeah, sure. For that purpose, patterns are very useful, Wayne, as Jose and Tammy already said. Lou, I think it's confusing to refer to text-based requirements as written in natural language. Rather, we should say structured natural language. This is the approach in the guide for writing requirements, where the structure is defined within the characteristics for needs and requirements and sets of needs and requirements, which are formed per the set of rules in the guide. EARS also defines a structure. Many tools define templates as well. Those structural natural language is more representative of what we are talking about. Yes. For instance, I am working together with Jose Miguel Fuentes, Jose Fuentes, who is attending the session. We are in different companies. He's going to be our provider. But yes, we are working together to define the patterns, the ontology and the taxonomy we want to apply to the requirements. Not only the requirements, also the models, okay? So next slide. So question 2, yes, models can be used and in my opinion should be used to define requirements and needs. Well, this one last thing on this slide, this arrow here from bottom to top means that at the end some conclusions here impacted the needs of business requirements and customer requirements. So we updated in some cases the business and customer requirements, more customer requirements than business ones. We updated them according to conclusions taken here and here regarding operational behavior of the system. Okay. So next slide. This is another representation of what I just explained. Okay. First, in Skydweller, we already had the requirements. This doesn't mean that the requirements should be there first. It depends. In my opinion, probably it makes sense that high-level needs could be in place first, and then what I would do is to start modeling the needs and start derivating requirements from the models. But at Skydweller, we already have requirements. So what we did is use the requirements to create the models, and then use the models to improve the requirements. And that was an iterative process, okay? And iterative and recurrent. But if we would not have had the requirements, I would have started creating the models from the user needs or customer needs or business needs. Okay. So question 3, last question. Can models be used to improve the quality of requirements, completeness, consistency, and correctness? Yes, we've more or less already answered this question, but yes, can, and I think that should be used. If models are considered the source of truth, I think that models should be used to improve and to validate. I do not want to say validate because I've had some discussions on this. Used to review the work products of the left side and right side of the B, requirements, design, and verification test. Okay. So how can we use models to improve the quality of requirements? Well, what we did is, I already said that we, as part of the review gates of requirements, not the formal ones. When we reach one formal gate with requirements, we already had performed this peer review, these checks with models, okay? In order to not to wait until the formal approval of the requirements to improve the quality. And then had to create change requests and whatever. So we did it in advance before the formal review. So completeness. We required the engineers in the process that all the functions described in the model, functional decomposition, should be contemplated, taken into account into requirements. That is what I just mentioned before, unless one requirement per function in the respective subsystem or item. Also, we guided them to improve the quality, the completeness of their specifications, as we already had the functional architecture groups or functions. We guided them to create one chapter within their specs per each functional group reflected on the model for the respective subsystem or item. Okay, so each function should have at least one requirement. Each functional group should have one chapter in the requirement specification. Consistency. Well, we started to define a common ontology for models and requirements, okay, and needs. We did not achieve that goal while I was in the company, but I assume they're still, because it's not an easy task. They're still working on that. So in terms of consistency, and as we had the traceability between models and requirements, we guaranteed that the same terms, the same concepts were used in models and requirements. Okay. So regarding consistency is more than entirely. Yes, we can talk about that later, Lou, if you want. Okay. This is what we did. Okay. Correctness. Well, as we perform these peer reviews, iterative peer reviews, we had no specific number of peer reviews required, but I can tell that probably we had more than 5-6 peer reviews with each technical expert between models and requirements, between me and my MBSE colleagues and the technical experts. Okay, so that somehow helped us to assure that models and requirements were correct. Also, we had the formal reviews, but that's out of this scope. Okay. So I think that's all I wanted to tell you. If you want, we can discuss about this. I would like you to discuss and ask questions on this. John, can you give an example of how model-based is used to ensure these attributes? How do the peer reviews use the model to evaluate this? Yes. Well, we had some checklists based on the ARP and the INCOSE guide and on the lower levels based on DO 178 and 254, but those were more related to requirements itself to guarantee that models and requirements were coherent and consistent. What we did is just sit together, take into account that we all were in the process of learning how to do this. Maybe they already have some predefined checklist on this at the company, but we did not have that at that moment. So what we did is sit together, as I mentioned before, with the technical expert, for example, autopilot or actuators or landing gear. Sit together, review the models. I would explain the model to him or to her, and we would go through the requirements to see if everything is coherent and consistent. If what I had drawn in the model, what I had reflected in the model in terms of behavior and architecture interfaces was in the requirement, and if both were aligned, okay? If the interfaces I have defined, if the activities, actions I have defined were in the requirements, and if they were correct, if the model were correct, then next step was to read the requirements together with the expert and see if the requirements were complete according to the model, and well, for sure, if the requirements comply with the rules of INCOSE 2 requirements in terms of, you know, simplicity and so on. More questions? Yeah, Tammy says that you can unmute and ask your questions instead of writing in the chat, if you want, okay? How do you know if the model itself is complete, correct? etc. Well, you know it because we on the MBSE side knew how to model, how to create models with SysML, and thanks to the inputs from the technical expert, he or she is who had the technical knowledge. So all the technical knowledge for that specific subsystem has to be reflected in the model. If what the subsystem has to do is reflected in the model is complete. Okay. John Clark, our operational use cases needs and operational scenarios needs expressed as high-level functions. Yeah, correct. Are these high-level functions used to define high-level requirements? Yes. As mentioned before, we already had high-level requirements, and we compared those requirements with the list of high-level functions to detect inconsistencies. Are these high-level functions further decomposed into low-level functions? Yes, following the normal system decomposition process. Are these lower-level functions used to define low? Yes, yes. As explained, as I mentioned here, well, maybe it's not so clear on the slide, but yes, functions and requirements, models and requirements defined at subsystem level would be decomposed onto the next level. Okay, so functions, models, and requirements at subsystem level was the input for the next level to decompose into the next level. Okay, into item level. Do functions define requirements, or do requirements define functions? Well, in my opinion, functions should define requirements. If you do not have requirements in advance, as it was the case, I would create the models, and then from the functional list, the functional decomposition and the functional architecture, I would create the requirements. Okay, but we already had requirements in this at the Skydweller. So what we did is to improve both in parallel. Yeah, we developed them concurrently. Yeah, correct. From a model perspective, I see correctness is something we need to ask if the requirement. Yeah, agree, Lou. Sorry, I'm going to read the question. From a model perspective, I see correctness is something we need to ask if the requirement as written reflect the intent as stated in the model. Is the stated action in the model reflected by how the requirement is written? Yeah, agree. And that's what we achieved. One of the goals we achieved in those peer reviews I just said before. Okay, we both together, technical expert and modeler, MBSE engineer, reviewed models and requirements, looking for correctness. Okay. From Carson, functions come first, derived from mission. Yeah, fully agree. Functions come first. Lou, again, from a model perspective, I see completeness as determining if all the inputs, outputs function in the model included within the set of requirements. Yes, again, agree. Wayne Wolf, at some point I'm wondering whether we will be able to use artificial intelligence to perform some of these functions. Essentially, partially automate peer reviews, but also be able to learn how to quality. Yes, Wayne. We are currently at Indra, we are considering to use one tool that allows us to do that. The tool will allow us to check the consistency between models and requirements, and to check the ontology between models and requirements. Even more, to check if this tool is capable to understand the language of the requirements and is capable to detect if following the ontology, if one interface, for example, or one action defined in an activity diagram has not been written in the requirements, or has not been written as it should, that is, using the same term Okay, so yes, artificial intelligence can help on that. Edgar Chong, is it worth the time, effort, and cost to convert a 40-year-old program that has used traditional system engineering into MBSE format? Oh, I don't know. I cannot answer to that question, Edgar. It depends. Has that program still live as to obtain benefits from moving into MBSE? I don't know. It depends. Yeah, Wayne, correct. It depends. John Clark, are needs functions validated, verified, or both? How can a need be verified?
I'd like to break in on this a little bit. During the last RWG Exchange Cafe, we spent about half of our time addressing that question. And I'll be posting that. That session has been posted on the Connect website. And so people can go and listen to that discussion.
Okay, thank you, Luke.
And that's at the same link that I just posted in there that this meeting information will be at as well. So people can go back and look at the prior month's meeting and you'll see a great lively debate on that very topic. Thank you, Lou, for mentioning that.
Okay, more questions. Kiffin, you don't have to dive in and do everything in the model at one time. You can start with a slice that helps you achieve and deserve. Yeah, in fact, that's what we did at Sky Dweller. We did not create the whole model at once. We started creating slice by slice. We did not create all the operational cases at the same time. Okay, we did not create all the activity diagrams for a specific subsystem at the same time. We started creating those we consider relevant, the most relevant from a functional point of view. Okay, not all of them. Ralph Hill, InnoSlate uses artificial intelligence to check quality of requirements. Thank you, Ralph. John, if everyone, including the customers and users on a project, understands and uses model-based, why do we need requirements? I think we do not need requirements if everyone understands model-based. As far as I know, Thales, you know Thales company, the creators of Arcadia and Capella, they're not using requirements for some internal projects, okay, because they all know model-based. More questions? A key capability that now exists is the ability to link requirements in a requirements management tool to requirements in a SysML model. A change in one tool is propagated to the other, helping ensure consistency. Yeah, very useful. Have you undergone a conversion from traditional system engineering to model-based? Not me. I'm not sure if any other attendant has done that, but not me. Sorry.
A lot of it depends on how you define model-based. The way I interpret that is traditional SE in the past has always been document-centric. And to me, what MBSE is really about is moving from document-centric to a data-centric view. So we create a data and information model of the system of interest, as well as all the artifacts that we develop as part of that. So needs, requirements, Our SysML models are all visualizations of that common data and information model. And so the real question is what meets the needs of each organization? For some organizations, they find SysML models are really important due to the complexity and all the interactions. But there's other organizations where SysML models really don't provide a return on investment, but the data-centric practice SE does have a big return on investment with traceability across the life cycle, ability to assess impacts of changes and so on. And so it's all what best meets the needs of an individual organization.
Yep.
Hi, and this is Tammy. I saw a question from Michael Tim regarding use of his requirements management tool for requirements. Is that considered model-based system engineering? And I would answer yes. Anytime that you're doing a data-centric view of your whole practice, you are in a model-based system engineering approach. Doesn't just mean a system model. However, the more data you have connected, the more you enable the best benefits from a model-based system engineering approach. So maybe it's not one tool, maybe it's tools that connect together, that get all of your source of truth in one spot where you can do queries and metrics and understanding of where things are, and you're not double booking stuff. So even use of a requirements management tool is doing the practice of model-based system engineering, but I don't think it's as complete as it could be for complex systems.
Yeah, I agree, Tammy. I think that yeah, if we use the requirements in a proper way, and the requirements are really the only source of truth, we are doing well. Maybe we do not have models as in SysML or Arcadia or whatever, but we have one single source of truth with the requirements, and that's maybe that's a more realistic approach to data centric than using models that not everybody knows to create.
Yeah, and the key is that we're in a data centric approach. We're not putting requirements in a silo separate from the other lifecycle processes. And the key is that we're providing traceability of all the data and information across the lifecycle. And so just that, that data structure of traceability is a model of our system of interest. Even if it's not communicated within a SysML type model, it still represents a model of our system of interest. And to many organizations, that's the only kind of model that really they need.
Yep. Yeah. Yeah.
A quick time check. We are at 5 till the meeting is over. So I know we have a few more questions. I'm actually really happy to see all the questions, but I'd like to now challenge at least one person to ask a question by unmuting. And we'll, you know, maybe we'll save some of these chat questions for another meeting, because I think having this discussion is really interesting. But let's give Luis a break, and maybe somebody can ask a question directly, and we can have a moment where we can have a dialogue, and then we can wrap up the meeting in 5 minutes.
Thank you, Tammy.
So who wants to go? Okay, come on, don't be shy.
Tammy, is there any chance that we can answer these questions offline? I don't know, in the if we have any tool or Teams channel or whatever to deal with these questions?
We do. And so what I'm going to do, well, first of all, I'll post the chat and make it available to everybody. But we have a Yammer site, and everybody in the requirement working group has been added to the Yammer site. And I think it'd be a really great idea to post some of these questions and allow different members to engage on that platform as more of a real-time interaction, because we can't always do these meetings in video form, right? Sometimes we can correspond through the social media channel. So please, if anybody would like to attend to our Yammer site, we've been trying to post things and not everybody's been responding. I think it would be a real beneficial use if more people were on there and we could collaborate that way. Okay, John, all right, John wants you to answer his question. John, do me a favor and unmute and ask your question. And then we'll have that one be our last one. John Clark, are you still there?
Yeah, I'm still here. Just need to get to the clicker.
Sure thing, thank you.
My question to Luis was, are needs, i.e. functions, validated, verified, or both? And secondly, how can a need be verified?
Good question, John. Thank you. Well, I'm after some discussions on what validation is and verification is, I'm not quite sure at this moment that I know the difference. But anyway, because it depends, what validation is depends on the stakeholder we are considering. For instance, we are validating the product when the stakeholder is when we are demonstrating to the customer that the product fits their needs. Okay, but I consider that we are validating needs or requirements when I demonstrate the internal stakeholders, for example, safety or quality assurance, that the requirements meet their needs. So in that sense, I am validating requirements. But verify requirements is to, probably Lou and Tammy know much more than me on this, but verifying requirements is to demonstrate that the requirement is correct. So in that sense, demonstrating to the internal stakeholders that the requirement is correct is also verifying. Anyway, are needs validated, verified, or both? Let's consider as the stakeholder, the only stakeholder, the customer, okay? So validate needs means to demonstrate the stakeholder that the product meets his needs or her needs, okay? Verify needs means to demonstrate that the needs are correct. How can a need be verified? In line with what I just mentioned, verifying a need is to check that the need is correct according to the rules defined for a need, according to the INCOSI guide in this case. Okay, so if we have a checklist to check that the need fulfills or comply with the characteristics of a need reflected on the INCOSI guide, we are verifying the need. To validate the need, we should demonstrate the customer at the end of the life cycle that the product meets their needs.
Yeah, Luis,
Okay.
that's very well stated.
Okay,
I couldn't
thank
say
you,
it
Lou.
better myself. You said it perfectly.
Thank you.
Okay, as a wrap up, I would like to quickly point our Yammer site out because some folks haven't had access to it yet. Are you okay, Luis, if I share my screen?
Yeah, sure.
Okay, stand by, please. I'm going to bring that up. I got to hit my share screen. And I think that's there. And one moment, I'm going to bring up the site. Okay, so hopefully everyone can hear and still see me. This is the Teams application. This is something that INCOSI has been developing. Most people know it from here, where we're all assigned either a member of a team or INCOSI everyone as is a common team. And they're starting to go more towards this platform. This platform is a way to keep us in communication and work on things. And I could develop a small RWG sub team on here, but probably not a team for all 400 plus members. But what they like to do is use this as a working platform. So as part of your NCOSE membership, everyone's been getting emails from Barkley Brown, our Chief Information Officer, and he has been setting up everybody with a Teams account. When you get into the Teams account with your NCOSE site, you can go to these 3 dots and there's communities. And that's Yammer. That's an application that's in there as part of Teams. And you can join communities. You can actually go to communities and see all of them. And you can join any community you'd like. Now, what we have been doing is trying to add you automatically to the requirements working group community. But if you have found that you're not a member or hadn't been added, you can hit a join community button. You notice I've already joined, but you can join a community. And then you can go to that community. And this is almost like our social media site where we can have conversations. I'll put links to things. I put our meeting announcement up. We've had various questions and answers. So this is a really nice opportunity for folks to kind of go back and forth on various topics like use of system models, various tools people have found useful, how they've managed to convert people over to a data-centric approach, tips and tricks. This is really the intention of these communities. And you notice we're not the only community. There are others that are starting to form as well. And this is a way to make NCOSE a little bit more interactive for the daily, practitioner out there. So I just wanted to give everyone that little snapshot. You also got chat features, Teams, calendar, and there's ways we can load files. So at some point they may be discontinuing the SharePoint site, not yet, but at some point. And I do want to make sure everyone knows today I'm still actively using our SharePoint site, and that is currently uploaded right now with all the information from today's meeting, minus the recording and chat, which I will post after the meeting. But we've got links to Lou's article. Ron Carson posted a YouTube video he has on this topic. I did that. I have the slides, and I'll get this meeting information up shortly after. So I just wanted to make sure everyone understood these different platforms and options that we have. I'm going to go ahead and stop sharing. And thank you, everybody. I think what we're going to do is, I think we're at time. So we're going to go ahead and conclude the meeting. Luis, thank you so much for presenting today. I really appreciate you sharing your experience in this journey of using your system model to help you with your requirements development.
Thank you, Tammy, for the opportunity. And thank you all, especially for your questions that I hope we can continue this discussion on the Yammer, because it's really interesting.
Excellent. Yes, Yammer is new and up and coming, and please use it. I would really appreciate everyone starting to use it. All right, take care, everybody. I'm going to stop the